Welcome back to my Commodore 64 Retro Games Memories. In this video, I'm going to have a little look at some of the tools that I use when I'm working on these videos. We're going to look at C64 Debug GUI, ICU64, and PDBMonitor. First up is C64 Debug GUI. This uses an integrated version of Vice with a C64 debugger. Unfortunately, this version that I use cannot be downloaded anymore, or at least the website has broken, so you can't actually visit it. I might try and put a zipped copy of this in some repository somewhere and put a link to it in the description below. So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel, or sending me a super thanks. They are always very much appreciated. On the left hand side of the main display window, we have these little icons on the icon bar. So the first one, which looks like a display screen, not the dollar but the display screen, just up above it, is like a full screen display. The next one along, the dollar one, actually shows the disassembly on the left, the screen up in the top middle there, the 0-page memory map, which can actually be scrolled around. It also includes some character displays, and it also includes the VIC state on the right hand side. This version, which I sometimes use, is the disk version, disk debug version. Now this includes the disk code on the right and the CPU on the left. This is like the disassembly version, so it contains the memory map, and then this is the expanded memory map view, so the large memory map view with the small display screen, the scrollable memory view on the bottom right there. This is kind of like a cursor following view, so the raster beam position is zoomed in on the screen, and there's the disassembly on the left hand side there, with the memory addresses and also the hex addresses for the opcodes and the parameters to the opcodes. I don't tend to use this view very often in the retro games videos or the demos peak videos, and that's because it seems to be bugged. Now I'm going to have to restart this one and reopen it, because then the emulation slows down, because this view seems to slow down the emulation somewhat. So this is a larger version of the raster targeted display. So basically where the raster is, it displays it as a great big zoomed in version of the screen. They're not terribly usable, these two views. So anyway, let's go back and reopen this one so that we can avoid the slowdown. I think that's a bug with this version anyway, so I don't use it. What I do tend to use in the technical videos are these ones here. So this is the VIC display light screen, so it allows you to drag the targeting cursor up and down for the raster, and you can see where the sprites are. I also use this one, so this is like a more detailed version of the VIC state debugging, and this one here is like a full screen painting version of the screen, so you can see the character set there. I'm just moving it off to the left, and then the sprite view, and then the screen view, the layers box. All of these are not really interesting to me. What's actually interesting to me is that you can zoom in and zoom out of this view, but it actually shows the full screen. But the really important thing that I do use a lot in the videos is that it shows the sprites with these red boxes around it, so you can actually see how many sprites are active on the screen. If you're wondering what this game is, it's actually a kind of like a version of the scroller game engine. This is just a technical demo to show all of the routines working together, the multiplexer and the scrolling routine. Now this view is like a VIC and SID and CIA 1 and 2 chip state view, and also the VIA 1 and 2, which come from the drive. This basically contains all of the IO chips, VIC chips, video chips, sound chips and everything else, and all of their state that you can see all on one screen, which, you know, can be quite useful. It even includes, look, a little drive LED state there, but these are the three waveforms of the three voices, and then there's also the filter volume state as well. I'm guessing that that's the combined output waveform as well. But anyway, this view is good because it shows you all of the sprites. And I do use this view often. Now this view is like the VIC view, so you can see the VIC state up in the top middle part of the screen there. You can also drag the targeting cursor up and down, and you can see on the left hand side, which is a really good useful feature of this, is that the targeting cursor on the left, well, the targeting cursor shows the opcode that's being executed on the left hand side. You can turn on and off these bad lines. Don't forget that the bad lines are where the VIC chip needs to fetch extra character and color information. Every 8 scan lines in the standard display screen. Don't forget, in some of my videos we talk about flexible line distance and also DMA delay, and also line crunching, so we can alter how often these bad lines occur. But basically, this zoomed out view shows all of the sprites all at once, which is great for getting an overview of the sprites that are actually used in the game. You can see how the game engine, the scroller game engine, scrolls around, and it has little, these are bullet effects. So I'm pressing fire, and it basically has, you know, bullet particles coming out. This is part of like a fully featured scrolling game engine that I actually use for a few of my projects. But what's really useful as well in the technical demo and retro games videos is that you can scroll up and down the screen and minutely analyze what's going on in the cycles. Now, when the screen is scrolling, look, we're getting some kill opcodes there. Now, this is a slight bug in this emulator, is that it's incorrectly showing the opcode. It's actually not executing a 0 byte instruction there. It's not executing a kill instruction. It's actually executing instructions from a ROM bank, because this is a cartridge code. It's actually executing load and store instructions, absolute load and store instructions, but the history for the targeting cursor for the raster beam there is just not showing the CPU execution history properly. So moving up and down the screen with the targeting cursor allows us to see what's going on, what instructions are being executed on what cycle, and also what the VIC chip registers are doing. So that's a quick overview of C64 Debug GUI and how I use it in my videos. Now let's go on to ICU64. ICU64, this is also quite an old version of the software. It also uses an integrated version of Vice, very old version of Vice, and to be honest, I'm not entirely sure that you can download this version of ICU64 anyway. Now, these tools, the versions that I have, are not the latest versions. They're certainly not the latest, the most recent or most up-to-date versions, but they are the versions that I use, and I use these versions specifically because I know they work, and I know the feature set in these versions very well. Sometimes later versions actually have a reduction in functionality, for example. So this is why I use this particular version of ICU64, is because it's got the independent windows, and you can have multiple independent windows open with different addresses and stuff like that too. So you can have 2 sprite windows open or 4 sprite windows open, and you can have 2 text screen windows open, for example. So we have the graphics map debug view for text screens. This shows, in text screen mode, it shows the 4 screens, top left, top right, bottom left, bottom right, each screen being 1 kilobyte in size. There you go, it's using version 2.3 version of Vice, which is actually really, really very old, but it works, right? It suits, it's just about fit for purpose. Also, this version of Vice, when you enable warp mode, it warps ahead really very quickly. Anyway, so this graphics map view, you can change what character set is being used for the display. So we changed it to C000, which is where I know where the character set is for this scrolling technical demo engine. And we can turn on and off multicolor by clicking the multicolor button. And when I scroll around in the Commodore 64, we can see how the character screen data is being updated in those two screens. And so that's why we know, or that's how we know, that games use either one buffer or two buffers, or sometimes even 3 or 4 buffers, is that we can look at the buffers as they are in memory. The graphics map also has a sprites mode, so we can have a look at the sprites that are available in memory. It also has a character set mode, or char sets mode, which is the character set mode that we can see in the graphics map view there at the bottom left hand corner. So the graphics map debug view for the sprites is there in the middle of the screen. And we can see when I press the fire button to emit those particle effects, if you like, the character-based particle effects, then those characters are shown in debug screens, as you would kind of expect. But of course the debug view in text screen mode doesn't show where all the sprites are. This is why the C64 Debug GUI is useful, because it shows you exactly where the sprites are. Let's close that window, and let's also close that window. Let's expand this window. So this is the memory view. This shows CPU memory reads and writes and executions. So if I zoom, and now I've zoomed in a little bit, you can see if I fire lots of character-based particle effects, then the yellows here and the greens indicate RAM reading and writing by the CPU. If I zoom in another memory view, which basically is just a duplicate of what's there in the other memory view, but I can zoom in with an independent zoom level, which is sometimes very useful because sometimes I want to concentrate on a particular range of memory addresses here, so I can zoom in and I can actually see the hex numbers. So we can see the address at the top of the square, CA4E for example, but the large 2 hex values there is actually the byte value for the memory cell, the memory address that we're looking at. If I press Control or hold down Control and then use the mouse wheel, I can actually increment and decrement the value, the hex value, the byte value inside that memory location. I can see there, look, it's actually updating the byte value in the screen data. If I choose a different address, you can see it's updating the byte value for the visible screen there. So if I scroll around, we can change the characters, the direction, or the character definition that's held in that memory. So this kind of memory analysis tool is really very useful for when you're looking for patterns. So you can see that there's a great big blob of blue in the middle of the memory view there, in the CPU events memory view there. And that blue indicates that the CPU is actually executing instructions. So blue is execution, green is, I think, read, and yellow is write. There's also red, which I think is reading and writing at the same time, if I remember correctly. I'm not entirely sure. Now, this monitor view, you will see me open the monitor view quite often in the technical videos that I do. Now, the monitor view is part of Vice. In my version of Vice I'm currently running, you press Alt and M and it opens up this monitor view. The monitor view is like the machine code monitor view that you sometimes found in hacking cartridges, but this has the ability to use different commands. To inspect memory, for example, the II command or the I command looks at a range of memory formatted in screen dimensions, and you can look at a memory range for that. There's a M command, which gives a hex dump of the memory for the memory range that you're going to give it. It also allows you to assemble or disassemble code, either in the monitor window itself, or you can actually open up the disassembly view for the computer, or you can have the disassembly view for the drive as well. You can also open up a register view for the computer or the drive if the drive is active. So this is obviously a disassembly. It contains the memory address, the bytes for each of the instructions, plus the parameters of the instruction if necessary, and then it contains the disassembly on the right-hand side. Because it's a monitor view integrated with Vice, you can actually assign labels to different memory addresses as well. So I've got a label file which, instead of the magic numbers, instead of the magic hex numbers there, like D016 and D015, you sometimes, if you don't remember exactly what those are, or D020 or D021, for example, if you don't remember what those are, I've got a whole bunch of defined memory addresses for those as well. So they become D015 becomes VIC2 sprite enable, for example. D016 becomes VIC2 screen control H, and D011 becomes VIC2 screen control V. When programming, it's a lot easier to remember, especially with code completion. It's a lot easier to remember the more verbose label names, the descriptive label names. You can start typing in SID, or you can start typing in volume, or you can start typing in enable or scroll, for example, or screen. And then the code completion will give you a drop-down list of label hints that it thinks that you need. So it's actually a lot easier to program, especially when you're using a cross-assembler, to use these more verbose label statements rather than trying to remember all of the magic numbers for the VIC chip and everything. I remember all of the magic numbers too, but that's because I used to program way back in the day when I was, like a teenager. And back in those days, the assembler only let you use magic numbers and very short labels for, branches and jumps and stuff like that. Space was at a premium in source file, right? So the disassembly view, for example, it shows you the disassembly, but it also completes the label names for addresses that it can resolve from the labels that you've loaded up. So the way to get help on the monitor is to look at the Vice emulators documentation, or you can bring up the help command actually in the monitor itself, and it will show all of the all of the commands that you can use. But there aren't that many commands, and if you're using the monitor relatively often, which is what I do, then you tend to remember what the commands are. They're kind of like standard. X is, exit, and it allows the CPU to execute until you hit a breakpoint, for example. So let's put a breakpoint at 8,000, for example, and then scroll the screen. You can see here, look, the ROM code. This is executing code from the cartridge ROM. It's load and stores in absolute address. If I change it to bank RAM, you can see the RAM underneath it. Change it back to bank CPU, and you can see the code which the CPU can see from the cartridge. So this is a very fast way of scrolling the screen by using completely unrolled speed code or fast code, and then storing it in the cartridge. I used this technique years ago for this kind of like scrolling engine game demo. It's the fastest way of scrolling the screen without using DMA from something like a RAM expansion or something like that, or without adding a super CPU. It's just a normal cartridge, just mapping in completely unrolled speed code to scroll the screen. And of course, the source code for this scrolling game engine is actually in my GitHub as well. I will put a link in the description below, and you can look through the code, and you can take parts of the code, and you can edit it and everything else. It's completely free for anyone to use, like all of the turbo loader code and everything else like that. So we can see here, I've got the wrong. So I'm just loading up Visual Studio. So I tend to use Visual Studio as my code editor. Sometimes I use Notepad++, sometimes I use a different editor, but mostly I use Visual Studio because it gives me the ability to, yes, it's using 24 sprites currently in the scroller demo. So yeah, 24 sprites scrolling on the screen. But I tend to use Visual Studio because it gives me a nicely ordered and structured project file layout, which some other editors don't give you out of the box. And I'm comfortable with the editor in Visual Studio as well. You can assign key project build settings and stuff like that, and debug settings. So the last tool that I tend to use, that you sometimes see in my videos, is the PDB debugger. So we'll have a quick little look at that too. We'll have a look at that with the Flying Shark version that I worked on. So one of my videos was replacing the disk loader in Flying Shark to use a compressed disk loader and actually making it to be file copyable. I sometimes use this more modern version of Vice, and it has the windows in a slightly different layout, and that's because I've just got the screen expanded in the bottom right hand corner and then the windows for the monitor windows there, but it's the same kind of monitor. But this is a PDB monitor window. This is a separate application. This separate application allows me to debug with source code and with optional mixed disassembly by using the remote monitor, which is part of more recent versions of the Vice emulator. So the remote monitor is like a network connection, a TCP connection basically, to a specific port. It's an external monitor connection, and this PDB monitor tool connects to Vice using that, but it basically augments and improves all of the code views to include source level debugging. So say for example, the game code for Flying Shark is saying it's initializing the drive. I can show the disassembly and I can show the source code view for what the Commodore 64 is running. So the Commodore 64 is running this code from irqdisk.a, currently line 58, for example, and it's JSRing to read ST, but previously it was JSRing to CI out, for example. These are ROM routines, but you can see it's using full source level debugging, and it knows that because the Acme assembler that I've been heavily tweaking to add all of this extra functionality produces a PDB file which matches or maps the Commodore 64 or the drive's memory addresses to line number, source file, etc., etc. So it enables me to create this very detailed disassembly view and also mix it with the source code view as well if I want. So I can mix disassembly and source at the same time, and we can see now that we've got the disassembly on the left with the memory address and the byte opcodes and everything else, and then the real source level view on the right hand side too. Now this kind of tool is extremely useful for when you're trying to debug what's going wrong, or hopefully right, with the code that you're currently working on. So the disassembly view in the standard Vice monitor is okay, and if you add label definitions, it's better, but it is not quite the source code. So sometimes when you're debugging, you want to debug with the source code and also the disassembly at the same time. So this is what this does. I'm changing the context here, so you can choose between the context for the view that you're looking at. So if you have overlapping memory ranges in the Commodore 64, so sometimes you'll have one bit of code loaded or the other bit of code loaded, you can choose which source code is mapped to a particular memory range. Now, this view here is side-by-side Commodore 64 debugging view on the left and drive code debugging view on the right. The drive code was also assembled with the Acme assembler, and also the PDB file was produced for the drive code as well. So this monitor view has simultaneous source code level debugging of drive code and C64 side code as well. So this allows, for example, drive code debugging along with Commodore 64 debugging at the same time. So you can actually see what code is executing in the drive, and you can see what code is executing on the Commodore 64. And you can choose if you want to disassemble one side, say for example the 64, while having source level debugging in the drive code, or you can add disassembly for both, or you can mix and match your views depending on what you want to do. So if I step over, for example, the store instruction here, the store instruction actually looks like it's storing at 100 in hex, comma y, right? Because that's what the source code says. But I can see that it's actually a self-modifying piece of code there, because I can see that there's, an inc of store high, for example, which points at the high address for this absolute store, comma y there. So if I mix it with the disassembly view, I can see that the disassembly view actually has the self-modified address of A000, comma y in hex, whereas the source code only has, $100, comma y. So this is where the mixed disassembly view and the source code level debugging view come in handy. So you can see how self-modifying code reflects its changes in the disassembly, but of course it's not going to reflect those changes actually in the source code itself, because the source code doesn't update when the Commodore 64 updates its memory. There are other different views as well, but we're not going to go into too much detail of those because I didn't include those in the technical videos. The technical video about debugging Flying Shark development for the improved disk loader did use this tool, so that's why I'm going through this tool, because you would have seen it in some of my other previous videos. So during the game, where it's loading the file data for the level, so for level 1, I think there are 3 or 4 files that it loads, we can still see, for example, that the source level and disassembly view for the drive code, we can see that it's executing drive code from IRQ disk drive code.a, and it's at line 444. And we can see on the Commodore 64 side of things that the Commodore 64 is running the IRQ drive code. And actually, if we keep on stepping out, we'll be able to see that it's actually stepping into the RNXP compression code as well. So this is the code which fetches bytes from the drive using either the kernel, CHRIN kernel function, or the IRQ disk loader. But then it feeds those individual bytes to a decompression routine, and this decompression routine is stored in decompression u reference long offset.a, which is the reference implementation of the decompression u method, which I've been working on. But anyway, this decompression algorithm is really very optimal at compressing data on the Commodore 64. So it basically pulls bytes from the drive and then decompresses the data as it's coming down from the drive into the Commodore 64's memory. So it's a nice little demonstration of how to hack and pack, or hack and crack and pack again onto a disk so that files are nicely compressed and everything else like that. And this kind of tool just helps you to side-by-side debug Commodore 64 and drive code. The PDBMonitor also has like a character set view where you can scroll through the memory and you can look at different character set data, but it is not as good as the view of ICU64 with the graphics map debug views and everything else like that. So this view was just included as an interesting project to just try and add this functionality in there. But because it's using the remote monitor, it's not as fast as the direct memory injection or whatever it is that this ICU64 debugger uses. The monitor view the monitor connection really wasn't set up to try and transfer huge amounts of data every Commodore 64 frame. And then sometimes in my videos you might see me use this very, very new, or this relatively new version of Vice. This is a newer version of Vice, or the more recent version, not the most recent version, because they keep on producing new versions. But this version is I think the GTK version, and you can see that the monitor window, if it pops up, it's Alt H instead of Alt M in this version. But the monitor window is just a single monitor window. It doesn't have the separate disassembly views that this slightly older version of Vice has. And to be honest, I prefer the older version of Vice, this version specifically, because it has the separate disassembly view, the separate memory view, the separate register window view and everything else like that. So I tend to use this version of Vice more often than not, because I know that it works, and it works in a way that I find to be user-friendly. I find that the monitor window doesn't work that well in the new version of Vice, so that's why I don't tend to use that version. I wish sometimes that the new version of Vice would actually keep, the functionality rather than breaking the functionality, but hey ho, never mind. So most of the time when I'm debugging code in Vice, I will be using the PDBMonitor with this version, older version of Vice. And this is basically my development setup, along with Visual Studio to do all of the code editing and project management and building and everything else like that. So I think we'll leave this video there. I've already covered the tools that I mostly use that you'll see in my technical deep dive videos, the demos, peak videos, and the retro Commodore 64 games videos. So I hope you enjoyed this video. It was because several people had requested videos about the tools that I use that I thought I'd go into a little bit more detail about the tools that I currently have. I will try and put a download link in the description below for these tools because they can't be downloaded from anywhere else. So thank you very much for watching. I hope you like these videos, and if you do, please do consider liking or subscribing to this channel, and I hope to catch you around next time. Have a great day, evening or night, wherever you are.